Welcome, deep divers. Today, we're really plunging into something pretty critical for modern IT. VMware Cloud Foundation, VCF.
Mhm.
Think of VCF as, well, the brains behind your private cloud. It's this incredibly comprehensive platform really designed to automate deploying and managing a whole software-defined data center.
Yeah, it's the engine that lets organizations run their apps with a kind of agility and efficiency that honestly was hard to imagine before.
Definitely. Now, for this deep dive, we're taking a slightly different path, maybe a bit unconventional, but I think it's really effective.
All right.
Instead of just talking high-level concepts, we've sifted through a set of, well, practical scenarios, almost like practice questions, the
Yeah.
kind that really get to the heart of operating VCF.
I see. So focusing on the how and why.
Exactly. It gives us a shortcut to understanding not just what VCF does, but why certain features and components are just so crucial in the real world.
That's actually a great approach. It cuts through a lot of the, let's say, the marketing fluff
Right.
sometimes. By looking at it through these functional lenses, you quickly see the design choices, the operational priorities. Basically what drives the efficiency, the security, the scalability you need in big IT setups.
Mhm.
It's about pulling out those core insights, those sort of aha moments from how VCF is actually built and run day to day.
So our mission today is to extract those really important insights about VCF's architecture, how it's deployed, the daily operations, and those critical security layers.
That's good.
By the end, you should have a much sharper picture of this powerful platform and, maybe more importantly, why these specific elements matter so much for any modern cloud setup. Ready to jump in?
Let's do it.
Okay, so when we talk about deploying an entire cloud stack like VCF, this isn't someone clicking through wizards for weeks, is it? It sounds like a huge undertaking.
Oh, absolutely not. Yeah, doing it manually would be, well, incredibly complex and error-prone. A recipe for delays, really.
So what are the key automation tools that kick things off? Our sources pointed to something specific for that initial part.
You're right. For that foundational setup, the absolute critical piece is VMware Cloud Builder.
Cloud Builder.
It's the dedicated tool just for that very first phase. It automates installing and configuring the core management domain. Think of it as laying the cornerstone perfectly.
So Cloud Builder puts down that, validated first block. What's the real takeaway here? The Blinkist version, if you will. How does this initial automation change the game for risk and timelines compared to, the old ways?
Well, it fundamentally changes the risk profile and the speed. Hugely.
How so?
Instead of potentially weeks of painstaking manual setup, crossing fingers across different teams, Cloud Builder gives you this perfectly validated, consistent foundation in hours.
Wow, okay.
The insight really is that VCF uses Cloud Builder to front load all that validation. So everything you build on top later starts from a known, stable, correctly configured base.
Right, no guesswork.
Exactly. It radically slashes those post-deployment fires and massively speeds up the time it takes to actually get value from your cloud infrastructure. It's all about achieving that perfect initial state reliably every single time.
That's a massive difference. Okay, so Cloud Builder sets this pristine stage, gets the management domain up. What happens next? What takes over for the broader deployment, the full VCF environment and keeping it running? Because VCF is way more than just that first domain.
Precisely. Once Cloud Builder has done its specific job, established that initial beachhead, let's say, the heavy lifting for the rest of the VCF environment, and importantly, its entire lifecycle management, patching, upgrading, expanding, all that, shifts to SDDC Manager.
Yes, SDDC Manager. Got it.
That becomes the central automation and orchestration engine for the entire VMware Cloud Foundation stack. It's the main controller.
And what would you say is its main role during that deployment phase? What makes SDDC Manager so, central?
Its primary job is automating and orchestrating the deployment and configuration of the whole VCF environment. And that includes things called workload domains, which are separate pools of resources.
Okay.
It's really the brain of the operation. It automatically builds out and configures the full stack. That means vSphere for compute virtualization.
Right, the hypervisors.
vSAN for the software-defined storage.
SX. Right.
And NSX for all the network virtualization and security. And then any of those workload domains you need for different applications or teams.
So administrators aren't stitching this together piece by piece.
Exactly. No manual integration of these core components. The key insight, I think, is that SDDC Manager provides this single, consistent control plane for everything, from getting it deployed initially to all the day two stuff like patching and upgrades. It makes managing cloud infrastructure at scale just dramatically simpler and way more consistent.
That makes sense. Okay, deployment tools covered, Cloud Builder first, then SDDC Manager takes the reins. Let's zoom in a bit. What are the actual building blocks, the fundamental pieces that make VCF work? What's a core element everything else sort of relies on?
Well, at its heart, VCF is built on proven VMware technologies. So a really fundamental building block is the vSphere cluster.
Okay, a vSphere cluster. So within VCF, what does that actually mean? How is it defined?
It's actually pretty straightforward. A vSphere cluster is just a group of ESXi hosts.
Those are the hypervisors, the servers running the VMs.
Correct. The software running virtual machines directly on the physical hardware.
Right.
And all those hosts in a cluster are managed together by a single vCenter server.
Right.
And this setup, this cluster, is absolutely foundational. It's what enables those essential features like high availability or HA.
So VMs restart automatically if a host fails.
Exactly. Keeps applications online. And also Distributed Resource Scheduler, DRS.
Which balances the workload.
Yes. Automatically moves VMs around to optimize resource usage across the hosts in the cluster. These are core vSphere capabilities that VCF leverages.
Got it. So the real brilliance for VCF is how it takes these super reliable, familiar vSphere clusters and uses them as the foundation for predictable resilience and performance, right?
Sure is one.
The insight being, VCF isn't reinventing the wheel for basic compute. It builds on this incredibly robust, well-understood foundation. This lets the higher-level VCF automation, like SDDC Manager, focus on the bigger picture scaling, lifecycle management, knowing that the core infrastructure underneath is solid and essentially self-healing thanks to things like HA and DRS.
It's a very good way to put it. It leverages that solid base.
Okay, so VCF is deployed, it's humming along. Now operations kick in. How do administrators keep tabs on everything? How do they react when things change? Because things always change, right?
Always, yes.
You need to know if something's going wrong, or maybe if resources are getting tight. What VCF feature makes sure the system automatically flags things, sends a notification when, say, a component status changes or utilization crosses a line?
Right. In such a dynamic environment, you absolutely need proactive monitoring. You can't afford to wait for things to break. The feature you configure for those automatic notifications is simply called alerting.
Alerting. Okay, makes sense.
It's designed specifically to watch the health of components, resource levels, things like that. When a predefined metric crosses a threshold you set, the system generates an alert and can send out notifications, email, SNMP traps, whatever you configure.
So administrators get that immediate heads up. What's the core insight here? Why is effective alerting so important in a VCF world? Is it just about knowing faster?
It's more than just speed, though that's part of it. The real insight is that it fundamentally shifts operations from being reactive to being proactive.
Oh, okay.
Instead of finding out about a problem because a user calls complaining or because a system actually goes down.
Which is the worst way to find out.
Exactly. Alerting gives administrators that immediate visibility as things are changing, often before they become critical problems. This allows for much faster troubleshooting, quicker resolution, minimizing any potential downtime, and just generally maintaining service levels much more effectively. It's about building vigilance right into the system so you're always sort of ahead of the curve on potential issues.
Staying ahead of the curve. I like that. So beyond just getting those immediate alerts when something specific is off, how can admins get a broader view? Visualize trends, maybe customize how they see the overall health of their VCF environment. What feature lets them look at metrics and properties using, say, charts and personalized dashboards?
Yeah, for that deeper, more tailored visibility, administrators would use custom views and reports in VCF operations.
Custom views and reports.
Correct. This feature is all about letting you build your own personalized dashboards and charts. You can pick and choose exactly which metrics and properties you care about. CPU usage on certain clusters, network latency on specific segments, storage capacity trends.
Whatever matters most to you.
Precisely. And then display them in a layout that makes sense for your specific monitoring needs and workflows.
And the insight from that capability. Why are custom views and reports so valuable beyond just pretty charts?
The key insight there is around intelligent oversight, I'd call it.
Okay.
While alerts are crucial for grabbing immediate attention for acute problems, these custom views provide the context, the narrative over time.
Ah, the story behind the numbers.
Exactly. They let you spot more subtle trends, maybe identify performance bottlenecks before they trigger an alert, or even visualize data to demonstrate compliance or capacity planning. It really empowers administrators to move beyond just reacting to immediate fires and actually optimize the system's health proactively over the long term, making decisions based on data, not just intuition.
Data-driven optimization makes perfect sense. All right, let's pivot to security. Obviously huge in any cloud environment. How does VCF make sure the right people have the right level of access? And also, how does it ensure all that communication happening between the components is secure?
Two critical aspects, absolutely. Secure access and secure communication.
Let's take access first. So you've got a new team member joining. They only need access to their specific workload domain, maybe the dev environment, and you want to give them only the minimum necessary permissions. What VCF capability handles that?
Right, the principle of least privilege. For that scenario, you'd absolutely use role-based access control, or RBAC.
RBAC. Common concept, but how does VCF apply it?
VTF has a robust RBAC system built in. It's incredibly powerful because it lets you define specific roles like VM administrator or network operator and assign very granular permissions to those roles. Then you assign users or groups to those roles.
So you can tailor it very precisely.
Exactly. You can restrict that new team member to only manage VMs within their specific workload domain and prevent them from touching anything else, the management domain, other workload domains, storage settings, networking, whatever's outside their defined role. It strictly enforces that principle of least privilege.
So the insight here, it feels like RBAC isn't just about locking things down for security, but also about managing complexity at scale, right?
You've hit it exactly. The core insight with RBAC and VCF is that it provides surgical precision for access management across a potentially very large, complex environment. And yes, it's crucial for preventing unauthorized access, but it's also vital for things like compliance reporting and audits. It simplifies proving who can do what. Plus, it allows large organizations to safely delegate administrative tasks to different teams without creating security holes or giving away the keys to the kingdom. It's about empowering teams responsibly while maintaining strong centralized governance.
Empowering teams safely. Okay. Now, what about securing the communication between all those VCF services? SDDC manager talking to vCenter talking to ESXi hosts. How do you ensure that data flying back and forth is trustworthy and private? If an admin needs to update the SSL certificates, for instance, where does that task fit in?
Good question. Securing those internal communication channels is paramount. VCF relies heavily on digital certificates, SSL TLS certificates to do this.
Right, like websites use HTTPS?
Exactly the same principle. Certificates provide authentication proving services, are who they claim to be, and encryption for the data in transit. The task of managing these certificates, creating them, renewing them, replacing them when they expire or get compromised, all falls under certificate management.
Certificate management. Seems straightforward, but what's the deeper insight? Why is having a robust process for this so critical in VCF?
The insight is that certificates are fundamentally the backbone of trust and confidentiality within the entire VCF stack.
The backbone of trust.
Yes. Without valid, properly managed certificates, you can't be assured that the components are talking to the actual components they think they are, or that the data being exchanged hasn't been intercepted or tampered with.
Man-in-the-middle attacks and eavesdropping.
Precisely. Effective certificate management ensures that all those crucial communications between management services, hypervisors, storage, networking components are continuously secured. It's like a silent guardian, constantly working behind the scenes to maintain the integrity and privacy of your entire cloud infrastructure. It's foundational security hygiene.
Foundational hygiene. Got it. Okay, VCF clearly handles the basics really well, but it also seems designed for bigger, more complex scenarios. What about large organizations? Maybe they have multiple development teams, production environments, maybe even different business units, all needing their own space within a single VCF deployment.
Yes, VCF absolutely addresses those enterprise-level challenges. Things like strict resource isolation between groups and ensuring consistent deployment practices across potentially many different teams or projects.
So let's take a specific case. A company wants to provide completely independent, isolated resources and management capabilities for its development team versus its production team. But they want to do it within one single VCF automation deployment. What feature lets them achieve that separation?
That specific capability is delivered through multi-organizational tenancy.
Multi-organizational tenancy? Sounds powerful.
It is. This feature essentially lets VCF administrators carve out logically isolated independent environments tenants within that single VCF instance. each tenant can have its own dedicated pool of resources, compute, storage, network, its own user directory integration, its own policies, and even its own set of administrators with permissions scoped just to that tenant.
So it's like having separate VCFs but sharing the underlying infrastructure.
That's a good analogy, yes. They get autonomy but share the efficiently managed core platform.
That seems incredibly useful for large companies. What's the key insight there? What does multi-tenancy unlock?
The insight is really about achieving operational autonomy with shared infrastructure efficiency. Multi-organizational tenancy allows different teams, departments, or even business units to operate almost as if they have their own private cloud, with self-service capabilities, strong resource guarantees, chargeback, showback potential, but without the overhead and cost of building and managing entirely separate physical infrastructures for each one.
Right, leveraging the central platform.
Exactly. This translates directly into significant cost savings, much faster time to market when a new team needs an environment. And it provides that built-in isolation, which is often crucial for security, compliance, and just preventing noisy neighbor performance problems.
Makes sense. Now, once you have these separate tenants or environments, how do you make sure everyone isn't, reinventing the wheel? How do organizations ensure they're deploying virtual machines consistently, using standardized templates and approved OS images across all these different teams? There's a feature mentioned, a provider content library. What's its main job?
Yes, ensuring consistency across tenants is vital. The primary purpose of a provider content library in VCF automation is precisely that, to act as a central, curated repository. It enables the main organizational administrators to store and manage approved VM templates, ISO images, scripts, and other necessary content.
So it's the official source of truth for deployment content.
Exactly.
Yeah.
Tenants can then subscribe to this provider library. When they need to deploy a new VM, they pull the template or image from that trusted central source.
Okay, so the core insight about using a provider content library, how does it fundamentally change how operations work in a multi-tenant setup?
The key insight is about driving standardization and velocity while reducing risk.
Standardization and velocity.
Yes. It ensures that everyone, regardless of which tenant they belong to, is deploying from the same set of approved, up-to-date, potentially pre-hardened golden images and templates. This dramatically reduces configuration drift between environments, which is a huge operational headache. It significantly speeds up provisioning times because you're starting from a known good state. And it really helps enforce security and compliance standards consistently across the board. It's about making sure every new deployment is ideally a perfect compliant clone, not some custom, potentially insecure snowflake build.
No snowflakes, got it. Okay, one last area, storage. We mentioned vSAN is deeply integrated. How does VCF, using vSAN, handle data resilience, availability, and maybe even performance for the virtual machines? It's not just about raw capacity, is it? There's intelligence there. What's the main purpose of a storage policy in vSAN?
You're absolutely right. It's about intelligent management, not just capacity. vSAN is a cornerstone of VCF software-defined storage, and its real power comes from policy-based management. The primary purpose of a vSAN storage policy is exactly what you hinted at. It determines the desired resilience, availability, and performance characteristics for virtual machine objects, their virtual disks primarily.
So you define the outcome you want for a VM storage.
Precisely. Instead of worrying about traditional storage concepts like aliens, RAID levels, zoning,
which can get very complex.
Very. Instead, with vSAN storage policies, the administrator defines rules based on application requirements. Things like, this VM's data must tolerate up to 2 host failures to tolerate, or FTT, or ensure this database VM gets at least 5,000 IOPS, or maybe use space-efficient RAID 56 for this archives data.
Okay, so you state the need, not the mechanics.
Exactly. You define the policy, often selecting from predefined ones or creating custom ones, and then you apply that policy to a VM or even individual virtual disks. vSAN then automatically handles the underlying data placement, replication, striping, whatever is needed across the disks and hosts in the cluster to meet that policy's requirements.
That sounds like a game changer compared to traditional storage provisioning. What's the real insight here? Why are these policies so impactful for VCF admins and the apps they run?
The insight is about achieving granular application-centric control over storage attributes automatically.
Application-centric?
Yes. It shifts the focus from managing storage infrastructure details to managing application service levels. Administrators can ensure that each workload gets exactly the level of data protection, availability, and performance it needs based on its business criticality.
Tailored storage per application.
Right. It provides incredible agility. Changing a policy is much easier than reconfiguring traditional storage, and it gives you high confidence that your critical applications are protected and performing as required, literally down to the individual VMDK level. It makes storage smart and responsive to application needs.
Consider how these levels of deep automation and policy-driven management we've discussed. They aren't just making IT tasks easier. They seem to be fundamentally changing the types of services and the pace of innovation that become possible in this digital age.
That's a really interesting point.
So the question to ponder is, what new possibilities truly emerge when your core infrastructure stops being a static limitation and instead becomes genuinely programmable, intelligent, and capable of adapting almost instantly to business needs? It's a powerful shift and definitely worth thinking about what comes next.